acyclic stereoisomer having the molecular formula C4H7Cl are classified and tabulated. Find out the correct set of numbers. So we have to find out how many geometrical and optical isomers are possible with C4H7Cl. This is an acyclic stereoisomer having formula this. So one asymmetric carbon is present in CH2 double bond CH, CCl, CH3, H. So it has one asymmetrical carbon atom. Therefore, number of optical isomers are 2 raised to n, 2 raised to 1 is equal to 2. Two geometrical isomers of each compound are possible from the following structures. CHCl double bond CH, CH2, CH3. This is the first structure. It will show two geometrical isomers. The second compound is CH2Cl, CH double bond CH, CH3. This will also show two geometrical isomer, and the third one is CH3, C, CH, CH3, and one chlorine attached here. This will also give us two geometrical isomers. So in total there will be 6 geometrical isomers and 2 optical isomers. Option A is the correct answer. At room temperature, the eclipse and staggered forms of ethane cannot be isolated because A. They interconvert rapidly, B. Both the conformers are equally stable, C. The energy difference between the conformers is large, D. There is large energy barrier of rotation about 6 bond. So in staggered and eclipse conformation of ethane, the basic structure of the ethane molecule and its various bond angles and bond length remain same. So bond angle, bond length remains same. Since the repulsion between the non-bonded hydrogen atom on 2 carbon are minimum in staggered conformation, hence staggered conformation is more stable than the eclipse conformation by about 12.55 kilojoules per mole. Further, since its energy barrier is this much, which is very small and can be easily met, the collision of the molecules at room temperature. Hence, these two conformers of ethane are readily interconvertible forms of ethane and hence cannot be separated at room temperature. So option A is the correct answer. Which of the following has the smallest heat of hydrogenation per mole? A 1-butene, B trans 2-butene, C cis 2-butene, D 1,3-butadiene. 1,3-butadiene shows smallest heat of hydrogenation due to its higher stability, which is due to resonance. Trans 2-butene is more stable than cis 2-butene on the basis of heat of hydrogenation. 1-butene is least stable than 2-butene due to hyperconjugation, while 1-butene due to hyperconjugation show two no bond resonating structure. Resonance is more powerful than hyperconjugation. So order of stability will be D, B, C, then A, and heat of hydrogenation will be A, C, B, and D. So option D is the correct answer. The correct order of dehydration of the following is: the compound 3 dehydrate most easily and it leads to the formation of aromatic compound benzene ring. So it can be most easily dehydrated. Compound 2 dehydrate less easily than compound 3 but more easily than 1 due to formation of stable conjugate diene. So compound 2 will lead to formation of a most conjugate stable diene, and the compound 1 is most difficult to dehydrate. as there is no double bond already present. So it leads to formation of one single in aromatic compound, which is not at least aromatic. So the most stable is and the most easily dehydrated, which will have already present double bond. So compound 3 can be dehydrated more easily than compound 2, then compound 1. So option B is the correct answer. Which one of the following conformation of cyclohexane is least stable? A. Half chair, B. Boat, C. Twisted boat, D. Chair. The half chair can be attained by moving the carbon C1, C2, C3 and C4 of chair conformation. The structure of chair conformation will be this, while that of half chair is this is half chair. So C1, C2, C3 and C4 of chair conformation into one plane, and C6 above the plane and C5 below the plane. It contains many eclipsed carbon hydrogen bond. The half chair conform lies about 10.8 kilocalorie above the chair form. So option A is the correct answer. Which of the following act as nucleophile? Of all the compound, nucleophile are the species which are electron rich, which has more number of electrons or lone pair in their structure. CH3NH2 has a lone pair on nitrogen. RO minus has a lone pair on oxygen. CH3MgBr has lone pair on bromide ion. So all these are nucleophile except AlCl3. AlCl3 is an electrophile which is having 3 lone pair and has one deficient pair of electrons. So it is an electrophile. Option C is the correct answer. Which of the following pair represents stereoisomerism? A. Chain isomerism and rotational isomerism. B. Structural isomerism and geometrical. C. Linkage isomerism and geometric. D. Optical and geometric. When isomers have structural formula but differ the relative arrangement of atoms of groups in space with the molecule, these are known as stereoisomerism. So differ in the structural arrangement in space. This is stereoisomerism. So the stereoisomerism is of 3 types: geometrical, optical and conformational. Geometrical has cis and trans isomerism. So option D is the correct answer. Ketoenol tautomerism is found in ketoenol form is a tautomerism structures C6H5 C double bond ON CH3 is the keto form and its enol form is C6H5 COH double bond CH2. This is enol form. Similarly, there is ketoenol form also found in C6H5 C double bond O CH2 C double bond O CH3. This is the keto form and its enol form is C6H5 C double bond O C H double bond C. Here comes the alcohol CH3. This is the enol form of the structure. So structure C and D both have keto and enol form. Consider the following bromides. The correct order of SN1 reactivity is: reactive towards SN1 depends on stability of carbocation. So for SN1 reactivity, tertiary is greater than secondary than primary. So in the following structures, the compound B has methyl and bromide attached here. As there is double bond, it will lead to more reactivity towards SN1 reaction. And then comes the compound C. Here is branching which can be seen, but it is not seen any branching in the compound A. So for SN1 reactivity, the branching is also important. So here, because of the presence of double bond, the most reactive will be B. Then because of branching, the compound C and the compound A. So option B is the correct answer. Which statement is true for cyclohexane? A. It has two possible isomer. B. It has three conformation. C. Both conformation is more stable. D. Chair and both conformation differ in energy 30 kilojoules. So we have to find which is the true statement for cyclohexane. The chair and both conformation differ in energy with 30. The chair conformation is and the both conformation is they differ in energy with 30 kilojoules, which is the correct statement. There are more possible isomers for cyclohexanes, asymmetrical, symmetrical, and there are more conformations possible. And chair conformation is more stable than board conformation. So option D is the correct answer. Toluene was treated with bromine and iron, gives parabromotoluene as the major product because the toluene, the methyl group CH3 group is A. Paradirecting, B is metadirecting, C activates the ring by hyperconjugation, D deactivates the ring. So the given structure of toluene will be this. It reacts with bromine in presence of iron. So the product will be parabromotoluene plus HBr. CH3 group is able to activate the benzene ring by hyperconjugation. So methyl group shows orthoparadirecting influence on benzene ring. So option A and C both are correct options. Rotation of plane polarized light is measured by A. manometer, B. polarized meter, C. viscometer, D. refractometer. Polarimeter is an instrument used for measuring optical rotation. It consists of two nickel prism, one called the polarizer and the other called the analyzer. In between the polarizer and analyzer, a glass tube containing the solution of optically active compound is placed. So here a glass tube containing optically active compound is placed. So which will lead to a polarizing light. It is measured by a polarizometer. Option B is the correct answer. Which of the following compound is expected to be optically active? So in this, the structure, open structure will be carbon attached to hydrogen, aldehyde group, and 2CH3 alkyl group is attached. So the carbon atom does not have all the four substituents different, so does not show optical activity as there is no chiral center. Same goes with the second one. In third and fourth, in the fourth structure, the carbon has two bromine attached and one aldehyde group, and here one ethyl group is present. As this carbon does not has two bromine substituents same, so it does not have chiral center. In structure C, there is one hydrogen attached, one bromine, one aldehyde, and one ethyl group is attached. So this have chiral carbon, so it will show optical activity. Option C is the correct answer. For which of the following parameters the structural isomer C2H5OH ethyl alcohol and dimethyl ether would be expected to have the same values: A, boiling point; B, vapor pressure at the same temperature; C, heat of vaporization; D, gaseous density at the same temperature and pressure. The gaseous density of both alcohol and ether would be same under identical conditions of temperature and pressure, while the rest of these three properties, that is vapor pressure, boiling point, and heat of vaporization, will differ, as ethanol has hydrogen bonding whereas ether does not have hydrogen bonding. So based on hydrogen bonding, this property, vapor pressure and heat of vaporization, will differ. So option D is the correct answer. Among the following, the aromatic compound is, according to Huckel's rule, aromaticity, the molecule must be planar, cyclic system having delocalized 4n plus 2 pi electrons, where n is an integer which is 0, 1, 2, 3 and so on. Thus, the aromatic compound have delocalized electron cloud of 2, 6, 10 or 14 pi electrons. Cyclopropanyl cation. This structure, the cyclopropanyl cation option A, has 2 pi electrons where n is equal to 0. So it is aromatic. So option A is the correct answer. The plus I effect of the alkyl group is in the order. The effect of plus I group on the primary carbon atom attached here is the CH3. The central carbonium carb cation will withdraw electrons, which is less stable or weak plus I effect than the secondary carbon atom, because in secondary the carbocation will have 2 CH3 electron donating, which is less stable than the tertiary, in which there will be 3 carbon atom donating their electrons. So the plus I effect is more pronounced in tertiary than secondary than primary. Among the following, the most stable compound is cis 1,2-cyclohexane diol, trans 1,2-cyclohexane diol, cis 1,3-cyclohexane diol, trans 1,3-cyclohexane diol. Trans configuration is more stable than cis configuration, because in cis configuration the hydrogen group are thrown close enough together to cause crowding or repulsion. Because of hydrogen group, again between 1 2 and 1 3 configuration, in 1 3 OH group are placed further apart to minimize the repulsion, hence the most stable is trans 1,3 cyclohexane diol. Optical rotation only when substituted by deuterium among the following compound 1 2 3. The correct order of reaction with electrophilic agent is, first is methoxy, second is benzene and third is nitro group. Methoxy group is electron releasing. Methoxy is electron releasing. It increases electron density on benzene nucleus, while NO2 decreases electron density on benzene. So the correct order will be 1 is greater than 2, then 3. That is methoxy, then benzene ring, then nitro. So option C is the correct answer. The number of possible isomers of the compound with molecular formula C7H8O is, remember that aromatic alcohols are isomers of phenols and ethers. So the structural isomer will be CH2OH and other alcohol CH3. This will have three structures: alcohol at ortho, meta, and para position, and the ether structure will be OCH3. So in total there are 5 isomers. Option B is the correct answer. Which pair shows cis trans isomerism? A. Malic fumaric acid, B. Lactic tartaric acid, malonic succinic acid, and crotonic acrylic acid. The structure of malic acid is carbon double bond COOH, hydrogen, hydrogen, COOH. This is the cis form, and the trans form is fumaric acid COOH. Here comes the hydrogen and one hydrogen. This is the trans form. This is fumaric acid, this is malic acid. So this is a pair of cis trans isomerism. Which of the following species is most stable? Nitro group is electron withdrawing group. It will draw electrons from the phenyl group attached to it. So it decreases stability. Methoxy group is electron releasing group. Hence it increases stability. It will give electrons to the phenyl group. Chlorine is also electron withdrawing, but its effect is lesser than the nitro group. So the order of stability will be first, second, third, and fourth. So option B is the correct answer. In a reaction of C6H5Y, the major product, that is 60%, is meta isomer. So the group Y is, the compound is phenol attached, there is a benzene ring attached to Y, X plus, and the reaction takes place in which we get a meta product. So we have to find Y is which compound, which is give meta isomer as the major product. So Y is carboxylic acid because it is meta directing group, while NH2, OH, NCl or are ortho and para directing group. So option A is the correct answer. The following reaction is described as. In this reaction, inversion of configuration takes place and is called as optical inversion. It is a typical example of SN2 reaction, which is bimolecular nucleophilic substitution reaction. There is inversion of the reaction as the bromide is on the right side, the alcohol group attached to the left hand side. So it is an example of SN2 bimolecular nucleophilic substitution reaction. How many chiral isomers can be drawn from 2-bromo-3-chlorobutane? So we have to find the chiral isomers. 2-bromo-3-chlorobutane has 2 chiral carbon atoms. As we can see, the structure is CH3, CH3, one hydrogen here, bromine and chloride. As these 2 carbons have all the substituents attached are different, so there are 2 chiral carbon atoms. So the formula is 2 raised to n, so 4 optical isomers can be obtained. Option C is the correct answer. Decreasing order of carbon-carbon bond length in the following structure given is. So the bond length is inversely proportional to bond order, and bond order is equal to bonding minus anti-bonding electrons upon 2. Hence bond order is highest for C2H6. So it has minimum bond strength. So option A is the correct answer. Which of the following has the most nucleophilic nitrogen of all the options? In option B, lone pair of electron on nitrogen is part of aromaticity, and in option C, NH group is adjacent to the electron withdrawing group, which is this. And in option D, lone pair is a part of resonance. So pyridine is most nucleophilic, option A. Which of the following compound is more acidic? Electron withdrawing group increases the acidic character. Increases acidic character due to minus I or minus R effect. So NO2 is electron withdrawing group. Hence the orthonitrophenol is more acidic. Carbon monoxide has same electrons, or the ion that is isoelectronic with CO is. Isoelectronic will have equal number of electrons. So CO has 6 plus 8, 14 electrons. Cn minus, that is cyanide, will have 6 plus 7 plus 1 extra electron is equal to 14 electrons. So these two species are isoelectronic to each other. Option B is the correct answer. The reaction X in the above reaction is, this is but 2-ine. So in the following reaction, ketone is formed, so it is oxidation reaction. So ozonolysis will occur. So the structure will be CH3, C triple bond C, CH3 in presence of ozone will give this product. So the reaction is ozonolysis in presence of O3. So X is O3, option C. Most stable carb anion is. Carb anion are the structures which is electron rich compound. Due to NO2 group in benzene ring, the structure CH2 minus NO2 is the most stable carbon ion because NO2 is electron withdrawing group. So option C is the correct answer.